Hey everybody, this is Mr. Longo here, and this video is going to cover function transformations. Now, I'm going to tell you that there are about 5 or 6 different transformations you're going to have to know, and some of them are very similar. So we're going to just start off by talking about them, and then we'll show you what they do, and then it's just going to be your job to know when we're using what. So the first thing we just got to cover is f of x is a parent function. So the parent function is given here. And I copied it into every graph just so you can see what's happening in each one. So when you have a negative sign in front of a function, that just means reflect whatever is given over the x-axis. If something is taking place on the inside after the x value, so if this was, x minus 2, that would be 2 units to the right. You would think left, but it's actually going to be opposite of what you think. And whenever we're inside, you have to think opposite. And after the function is going to be a vertical shift. In this case, it's up or down. So if you have something on the outside, that's plus would go up, minus would go down. And then, of course, we have compressing and stretching. If the multiplier is in the front of the function, it is a vertical stretch. And if the a value or the multiplier is inside of the function, it is a horizontal stretch or compress. But in this case, it's going to be opposite again. So whenever you're inside of the parentheses, you need to be very careful when you're thinking about it because it's most likely going to be opposite. And I'm going to show you some examples right now. So the first example we have is, what do you have when you have a negative f of x? Well, if this is our function, a negative f of x means we're just going to flip it over the x-axis. So if this coordinate is 4 below the x-axis, we're just going to transfer it to 4 above. And if this one is 4 above the x-axis, we're just going to reflect it over and graph it 4 below. And now you have reflected a function over the x-axis. Okay? Next example, we have f of x minus 2. Now, we're going to take these x minus 2 values. So, if we think about it, this coordinate 0. Think of what x has to be to give you 0. So, if you're thinking 2 to the right or 2 to the left, that would be a negative 2 minus 2 would be a negative 4. So, think 2 to the right. 2 minus 2 is 0. That's what's going to give us our 0. So, that's why when we're working on the inside, you have to kind of think about that. So x minus 2 means 2 units to the right. So you just move all 3 coordinates 2 units to the right and you'll see exactly what's happening. So it's the exact same graph. Nothing has changed except for the fact that we shifted it 2 units to the right. Now the vertical shift is going to take us at this just says let's take f of x and shift it down 3. So when you have a plus 3 on the outside, it would be up 3, but in this case we have a minus 3 on the outside. So that means all coordinates get shifted down 3 units. And here you go. Graph it, and it looks the same, just down 3. Okay, so those are your vertical and horizontal shifts, and also what a reflection over the x-axis does. The next examples are going to cover those stretches and compresses. So the first two are purple. And this one has the multiplier or the scale in front. So this is 2 times the function f of x. That means we're going to multiply by 2 and stretch it vertically. So this means our negative 4 comma negative 4, we're going to stretch it vertically. It's now going to become negative 8. And our positive 4 is now going to be stretched vertically and become a positive 8. And of course, 0 times 2 is still 0. So it's been stretched. Notice I didn't pull it left and right with the function here. This is a vertical. The number's out front, so we stretch it vertically by 2, not horizontally. So notice we're still on x equals 4. So if we had a 1/2, if it's less than 1, a fraction less than 1, it means it's going to get shorter. So half of the negative 4 is going to give us a negative 2. Half of the positive 4 is going to give us a positive 2. Okay, so that means it's going to be a little bit squattier. We vertically compressed it. So if it's a fraction out front, it is a vertical compress. But if the number in front is a number bigger than 1, or it could be a fraction bigger than 1, like 5/2, that is a vertical stretch. Okay? Now, we're going to jump to the next two examples, which you can see have the multiplier on the inside. Now, that means that when we are going to do this horizontally, we have to think opposite since it's inside. So you would think this is a horizontal stretch, but it's actually a horizontal compress, and it's by the reciprocal, so it's actually 1/2. So instead of stretching it to the right by 2, we actually are going to shrink it up by 2. Or half of it. So then we're going to go half of the -4. So notice this time we looked at the x values. We went left and right instead. Now I want to show you something really cool here. Let's continue this. That's up 4 over 2. So let's go up 4 more over 2. I want you to notice that we are now at 4, 8. And if we were to just go down 4 and over 2 more, we would be at -4, -8. Go back over to the first example we had here. That's like factoring out a 2. That's 2 times f of x. So the inside, the horizontal expanding and compressing, that's kind of, we could get away with it by factoring out something. But I just want you to know what it means if it's inside. So this one, of course, would be a horizontal stretch because it's inside, but it's by a factor of 2. Okay, so we're actually going to pull this 2 times, or a multiplier of 2. So that's going to take us to 8. This guy's going to take us to -8. And you can see that we are now stretching it horizontally. Okay, so that's what the different stretches do. You must be careful with it. But like I said, we can apply these to anything. So we're going to write some different functions using transformations. Here's some practice with that. So we're going to say that f of x is equal to x squared. So we're going to reflect this over the x-axis, and we're going to shift it up 3 units. So to write that, we would say x squared, 3 up comes after that, but the negative goes in front. Now, I like to use parentheses around the x values. It'll help you in case we have the left and right. Okay? So g of x, it's x cubed. So vertically stretch it by 3. So that means in front, we're going to put a vertical stretch of 3. But we're going to shift it 4 to the left. So now we have to think about 4 units to the left. Left and right is opposite of what you think. So inside the parentheses would go up +4. And now you would keep the cubed. Okay? So that is how we use transformations. So this one is a trick because it already has some stuff going on here. So we're going to shift it to the right 3. So right 3 would be a -3 on the inside. So this already has a +2. So if we were to go back 3 units, so we now have an x -1 on the inside. And of course it's still squared, but now we have 2 down. So it's already 3 down. So if we were going to go down 2 more, it becomes a -5. Okay? So that's how we take that function and shift it right 3 and down 2. All right? The last example here is a reflection over the x-axis and a horizontal stretch by 4. So for our last example, I want you to realize that we already have a negative x. So if we were to take a negative and turn it into a negative, it's now going to go away and we just have our positive x. And we're going to stretch it horizontally by 4. So this needs to stay inside of the parentheses. And it needs to be a reciprocal. Remember, horizontal stretch by 4 means we have a 1/4 on the inside. So again, these transformations are going to take some practice. This video is just a slight introduction. We'll have many more examples to go through, but that's just kind of a little way to give you a head start. All right, this is Longo and I'm out.
See you, bye.